Next question is: a DevOps engineer is using AWS code deploy across a fleet of Amazon EC2 instances in an EC2 auto-scaling group. The associated code deploy deployment group, which is integrated with EC2 auto-scaling, is configured to perform in-place deployments with code deploy default.only at time. During an ongoing new deployment, the engineer discovers that, although the overall deployment finished successfully, 2 out of 5 instances have the previous application revision deployed. The other 3 instances have the newest application revision. What is likely causing this issue? A. The 2 affected instances failed to fetch the new deployment. B. A failed after install lifecycle event hook caused the code deploy agent to roll back to the previous version on the affected instances. C. The code deploy agent was not installed in 2 affected instances. D. EC2 auto-scaling launched 2 new instances while the new deployment had not yet finished, causing the previous version to be deployed on the affected instances. Correct answer is D. Next question is: a company runs a 3-tier web application in its production environment, which is built on a single AWS CloudFormation template made up of Amazon EC2 instances behind an ELB application load balancer. The instances run in an EC2 auto-scaling group across multiple availability zones. Data is stored in an Amazon RDS multi-AZDB instance with read replicas. Amazon Route 53 manages the application's public DNS record. A DevOps engineer must create a workflow to mitigate a failed software deployment by rolling back changes in the production environment when a software cutover occurs for new application software. What steps should the engineer perform to meet these requirements with the least amount of downtime? A. Use CloudFormation to deploy an additional staging environment and configure the Route 53 DNS with weighted records. During cutover, change the Route 53A record weights to achieve an even traffic distribution between the 2 environments. Validate the traffic in the new environment and immediately terminate the old environment if tests are successful. B. Use a single AWS Elastic Beanstalk environment to deploy the staging and production environments. Update the environment by uploading the zip file with the new application code. Swap the Elastic Beanstalk environment name. Validate the traffic in the new environment and immediately terminate the old environment if tests are successful. C. Use a single AWS Elastic Beanstalk environment and an AWS OpsWorks environment to deploy the staging and production environments. Update the environment by uploading the zip file with the new application code into the Elastic Beanstalk environment deployed with the OpsWorks stack. Validate the traffic in the new environment and immediately terminate the old environment if tests are successful. D. Use AWS CloudFormation to deploy an additional staging environment, and configure the Route 53 DNS with weighted records. During cutover, increase the weight distribution to have more traffic directed to the new staging environment as workloads are successfully validated. Keep the old production environment in place until the new staging environment handles all traffic. Correct answer is D. Next question is: a company wants to adopt a methodology for handling security threats from leaked and compromised IAM access keys. The DevOps engineer has been asked to automate the process of acting upon compromised access keys, which includes identifying users, revoking their permissions, and sending a notification to the security team. Which of the following would achieve this goal? A. Use the AWS Trusted Advisor generated security report for access keys. Use Amazon EMR to run analytics on the report. Identify compromised IAM access keys and delete them. Use Amazon CloudWatch with an EMR cluster state change event to notify the security team. B. Use AWS Trusted Advisor to identify compromised access keys. Create an Amazon CloudWatch events rule with Trusted Advisor as the event source, and AWS Lambda and Amazon SNS as targets. Use AWS Lambda to delete compromised IAM access keys and Amazon SNS to notify the security team. C. Use the AWS Trusted Advisor generated security report for access keys. Use AWS Lambda to scan through the report. Use scan result inside AWS Lambda and delete compromised IAM access keys. Use Amazon SNS to notify the security team. D. Use AWS Lambda with a third-party library to scan for compromised access keys. Use scan result inside AWS Lambda and delete compromised IAM access keys. Create Amazon CloudWatch custom metrics for compromised keys. Create a CloudWatch alarm on the metrics to notify the security team. Correct answer is B.